Hello everyone.
Welcome back to Digi Cyber Net Academy. In our last episode, we talked about the network device hub. We learned how hubs work as simple, non-intelligent devices that broadcast data to all connected devices, creating many collisions. If you haven't seen that episode, do check it out. Today, let's move one step ahead and talk about another important network device, the bridge. So, what exactly is a network bridge? Imagine you have two separate segments of a local area network, perhaps in different departments of an office, and you want them to communicate, but without all the traffic from one segment flooding the other. That's where a bridge comes in. A network bridge is a computer networking device that connects two or more separate network segments, essentially making them act as a single, larger network. It operates at layer 2 of the OSI model, the data link layer, which means it understands and uses MAC addresses to make forwarding decisions. Unlike the hub, which is a layer 1 device, the bridge is considerably more intelligent. The primary function of a bridge is to filter network traffic. When a bridge receives a data frame, it examines the destination MAC address. It then checks its internal table, often called a MAC address table or forwarding database, to see which segment that MAC address belongs to. If the destination device is on the same segment as the source, the bridge simply drops or filters the frame, preventing it from crossing over to the other segment. This saves bandwidth and reduces unnecessary traffic. However, if the destination MAC address is on the other connected segment, the bridge will forward the frame only to that specific segment. Is a bridge intelligent? Absolutely, especially when compared to a hub. While not as sophisticated as a modern switch, a bridge possesses a crucial level of intelligence. It can learn. It builds its MAC address table by observing the source MAC addresses of incoming frames, so it dynamically learns which devices are connected to which port, allowing for efficient, targeted forwarding rather than blind broadcasting. This learning capability is what makes it a transparent bridge. Devices on the network don't even know it's there, as it simply forwards traffic intelligently. Regarding ports, a traditional bridge typically has only two ports, connecting two distinct network segments. While some multi-port bridges exist, the concept of a bridge primarily revolves around connecting two segments. Does it have memory? Yes, the MAC address table we just discussed is its memory. It stores the MAC addresses and their corresponding port numbers, enabling it to make intelligent forwarding decisions. Now let's talk about collision domains and broadcast domains, crucial concepts in networking. In our previous video on hubs, we learned that a hub creates one large collision domain, meaning if multiple devices try to transmit at the same time, collisions occur, leading to retransmissions and slower performance. A bridge, by segmenting the network, breaks up collision domains. Each segment connected by a bridge becomes its own separate collision domain. This significantly reduces collisions and improves network efficiency, as devices on one segment can communicate without interfering with traffic on the other. However, a bridge does not break up broadcast domains. If a broadcast message is sent on one segment, the bridge will forward it to the other connected segments. This means all devices connected through a bridge remain part of the same broadcast domain, receiving all broadcast messages. Today, we rarely use traditional bridges because network switches have replaced them. Switches are faster, have more ports, better learning and filtering capabilities, and can handle large networks more efficiently. Switches are essentially multi-port bridges with advanced features. So, to sum up, a bridge is an intelligent layer 2 device that reduces collisions by segmenting the network, but it cannot break broadcast domains and has largely been replaced by switches. In our next episode, we'll talk about the network switch. We'll see how it improves upon both hubs and bridges, and why it's the standard choice in modern networks.